So good morning, students. So today's topic is electrical
Good morning,
transmission
sir.
lines. So so what exactly mean by the transmission lines, right? So, so what are the electrical power that is generated in the generating station, right? So electrical power is generated in the generating station is transmitted to the consumers with the help of the transmission lines, right? So whenever I talk about a transmission line, so it is a conductor or conductors designed to carry the electricity or electrical signal over larger distances, right? So what exactly transmission line is going to do? It transfers the electrical energy or electrical signal over larger distances with minimum loss and distortion, right? So that is called as the transmission lines. So the parameters associated with the transmission lines are resistance, inductance, as well as the capacitance and conductance. So these are the four parameters which are associated with the transmission lines. Now, whenever we take these parameters, these parameters are uniformly distributed, right? These parameters are uniformly distributed throughout the length of the line, right? So now, so whenever we want to design the transmission lines, so we need to have the sufficient knowledge about these parameters. Now, so what are the factors that are to be considered while designing the transmission line, right? So whenever we want to design the transmission lines, what are the factors we need to consider? So first one is the type and size of the conductor, right? So type and size of the conductor. Second one is efficiency of transmission. Third one is corona loss, and fourth one is power handling capability and power flow capability and stability. And finally, economic aspects. These are all the parameters which you need to consider while designing the transmission lines. So now, so how we are classifying the transmission lines? First one is the overhead lines, overhead transmission lines. So in which the three types are short transmission lines, medium transmission lines, as well as the long transmission lines. And second one is the underground cables. So now coming to the short transmission lines. So this will be given for different books. It will be given differently. So if the line voltage is up to 20 kV, so we can say that is a short transmission lines, and the length of the line is about 50 kilometers, right? So the length of the line is up to 50 kilometers, and operating voltage is 20 kV. So we can say it is a short transmission line. So in this short transmission line, capacitance is negligible, right? So how to calculate the power means, so percentage efficiency means, so it is the ratio of the power received at the receiving station by power delivered at the sending end. So that is a percentage efficiency. So next one is the other formula. So power received at receiving end divided by power received at receiving end plus 3i square r into 100%. So this is how we calculate the percentage efficiency. So for the short transmission lines, that is a equivalent circuit diagram, and you have the respective phasor diagram also. In that phasor diagram, what is happening there? So we are taking the receiving end current as a reference value, and VR will be the voltage which leads the current by 5R, and Vs is the sending end voltage which leads the receiving end current by 5S, and IR drop and IRX drop. So if you add that one to VR, we'll get Vs. So now, in the case of the medium transmission lines, so line voltage is moderately high, right? So in the case of the medium transmission lines, so voltage is a little bit higher. So it is greater than the 20 kilovolts, but less than the 100 kilovolts. And the line length is about the 50 to 150 kilometers. And here the capacitance is not negligible. It is considered, it's significant, right? So here coming to the long transmission lines. So whenever we have the line voltage more than 100 kilometers, we say that it is a what you can say long transmission line, and length of the overhead line is more than 150 kilometers, and line constants are considered uniformly distributed over the whole length of the line. So in this one, what are the line constants previously we have seen? Resistance, inductance, capacitance, conductance. These are all uniformly distributed over the whole length of the line. Now coming to the conductors which are used in the overhead transmission lines. What are the various conductors which you are using in the overhead transmission lines? So first one is ASCR or ACSR. So aluminum conductor with steel reinforcement. Right. So it's a most frequently used conductor, aluminum conductor with steel reinforcement. Similarly, we have the second one, aluminum conductor with alloy reinforcement. So second one is ACAR, aluminum conductor with alloy reinforcement. And third type of conductor we are using is hard drawn copper conductor, right? And fourth one is steel cored copper conductor. And next one is phosphor bronze conductor, galvanized steel conductors, and all aluminum conductors. So these are all the various types of conductors which will be making use for the overhead transmission lines. So next one is the that is a diagram. So overhead insulators, right? So what are the various type of overhead insulators will be making use? First one is the porcelain. So porcelain is what? It is a ceramic material. It is free from cracks, holes, etc. And its insulation resistance is very high, and dielectric strength is about 60 kilovolts per centimeter. So these are all the features of the what you can say porcelain material, right? So first one is what? It is a ceramic material, and it is free from cracks and holes, and its insulation resistance is very high, and dielectric strength is about 60 kilovolts per centimeter. So next one is the glass. So glass is what? It is cheaper than the porcelain, less stronger than the porcelain, and higher compressive strength than porcelain. So if you take the glass, it is cheaper than porcelain, and its strength is less than porcelain. It is having higher compressive strength. And synthetic resin. So next one is the synthetic resin insulator. Tensile strength is high, weight is low, comparatively cheaper. So these are features. So mechanical design of the overhead transmission lines. So how we are going to design the this particular overhead transmission lines. So transmission lines are designed primarily on the basis of the economic point of view, right? So based on the economic point of view, we are designing the transmission lines. But due to sag, it requires more conductor. Okay. So for keeping the cost minimum, sag also must be kept minimum, right? So for keeping the cost minimum, we need to keep the sag also minimum. But if sag is too low, then wire gets extra tension, right? So even if sag is going to be too low, what is happening? The wire will have more strength, more extra tension, so which may damage the conductor. So we need to see the proper value of the sag value. So if sufficient sag is not kept, then there is a possibility of mechanical failure of the transmission lines. So now when we are not keeping the sufficient sag, so what is happening there? There is a possibility of mechanical failure. So for favorable conditions, the required amount of sag and tension are calculated considering all the severe conditions like ice coating and wind pressure. So now, so what exactly the sag value should be means that should be calculated by considering all the conditions like ice coating and as well as the wind pressure. So considering all these things, we need to design the sag value. So now coming to the this advantage of overhead transmission lines, cheaper to install and maintain than underground cables, quicker to fix whenever fault develops. They have large transmission capacity, good cooling conditions. So these are all the advantages of the, what you can say, the overhead transmission lines. So next one is the disadvantages. So what are the disadvantages of the overhead transmission lines? So difficult to be erected when the network is complex and concentrated, right? So when the network is complex and concentrated, so it's difficult to erect. Not very safe to erect in densely populated areas. So wherever there is a densely population, so there we can't go for this particular overhead transmission lines. Also, it's not beautiful. So overhead lines, if you consider the beauty, it's not beautiful. Affected by the environment conditions such as pressure, temperature, wind, rain, etc. Influenced by thunder and lightning. So these are all the disadvantages of the, what you can say, overhead transmission lines. So coming to the underground cables. So underground cables is the replacement of the overhead cables, providing electrical power for overall telecommunications with underground cables. So either we are supplying the telecommunication systems or we are supplying the electrical power by means of these underground cables. So in thickly populated areas, the use of overhead lines is not practicable, and electrical energy is transmitted and distributed through underground cables. So whenever take the population point of view, so it is difficult to deliver the electrical power by means of the overhead system. So we'll prefer to have the underground cables. It is so what is the underground cable? It is a conductor provided with proper insulation. So underground cable is also a conductor provided with proper insulation. As voltage increases, the cost of insulation increases, and hence underground cables are restricted to low and medium voltage distribution. So whenever we are using this underground cables, so it is limited to a low voltages. So whenever we are going for high voltages, what is happening? The cost of insulation is increasing. So that's why what is happening? We are preferring this particular underground cables for only low and medium voltage distributions. Right? So you can observe that how we are constructing the underground cables. So totally we have what 1, 2, 3, 4, 5. The total 5 covers will be there for the underground cables. First one serving, next one is armoring, bedding, sheath, insulation. So these are all the 5 covering parts of the this particular underground cables. So now how we are classifying the underground cables? So by voltage, we're classifying as LT cables, HT cables, ST cables, right? And similarly EHT cables and extra super voltage cables. So these are all this is a classification of the underground cables, and so it is having a maximum capacity of low tension cables. Maximum capacity is 1000 volts. High tension cables, maximum is 11 kV. Super tension cables rating is between 22 and 33 kV. And extra high tension with a range of 33 to 66. And extra super voltage beyond 132. The next one is by construction. So by construction, we are classifying as belted, screen, and pressure cables. So in this belted cables, maximum voltage level is maximum rating is 11 kV, and in the case of screen cables, it is 66, and the pressure cables more than 66 kV. So this is how the underground cables have been laid. Right. So what exact dimensions means? We are going to dig a trench. So generally, its depth will be up to 1.5 meters and 45 centimeters wide in dug. And trench is covered with a layer of fine sand, and cable is laid over the bed. Next one is a drawing system. So in this one, what we are doing is we are taking the duct of cast iron concrete are laid in the ground with the manholes at suitable positions along with the cable road. Very less chance of fault occurrence. So in the case of drawing system, very less chance of fault occurrence. Next one is solid system. The cable is laid in open pipes or trough, dug out in earth along with the cable road. After the cable is laid, the toughing is filled and with the bituminous compound and covered over. It has poor heat dissipation facilities. So those are the types of laying systems. Next one you have is the advantage of the underground cables. Low chance of developing faults, low maintenance cost, not influenced by environmental conditions, more durable in comparison to overhead transmission lines. Underground cables are more safer for mankind, requires narrow band of length to install. The disadvantage is not very expensive, costs about 4 times overhead lines. Repairing of underground is not easy, it takes more time to repair. Maintenance cost is also very high. So this is about the transmission lines.